Hello, and thank you for joining me. Today we are going to be talking about virtual workstations on AWS for digital content creation with G4 instances. My name is Haley Cannell. I am a CG supervisor working with a team of AWS engineers building tools for animation and visual effects studios. My job at AWS is to test these cloud solutions in production scenarios to make sure that they are robust enough for real-world production studios to use. My background is in lighting and compositing for animation, and I have worked on all different types of projects throughout my career, including film, commercials, advertisements, and AR/VR. During today's presentation, I will be introducing you to the team within AWS that is focused on developing services for creative studios. I'll go over some cloud basics that are necessary components of building studio infrastructure in the cloud. We'll be talking about virtual workstations, of course, and then I'll discuss how you can get started moving your studio to the cloud. And finally, I'll talk through what it looks like when a studio finds success working entirely in the cloud. Let's get started. I'd like to start off by introducing you to the team that I work on. The Creative Tools organization within AWS is a group of engineers, artists, and everything in between. Many of my teammates have years of industry experience at studios such as DreamWorks, Pixar, Disney, Sony, Weta, ILM, and many others. Our goal is to help studios leverage the power of the cloud to empower their team. We are here to make sure that the very specific requirements that animation and visual effects studios demand can be met by the services that we provide. Our industry experience puts us in a really good position to understand what those requirements are. I personally have been doing production in the cloud for the past 5 years, and I work with a team of artists within Creative Tools whose job it is to push on the technology by doing production in the cloud. And our goal is to make the cloud more approachable to creatives and ensure that artists can work as efficiently in the cloud as they do on-premise. In order to stay connected with the animation and visual effects industry, AWS has become an Academy Software Foundation member. Our goal is to help define the future of open source and to educate ourselves about the latest technology that the industry is using. We want to ensure that the services that we develop cleanly integrate with the tools that studios are using, including open source. Several people on the Creative Tools team are involved with ASWF at different levels, including on the Technical Advisory Council and a variety of working groups. Along with these other members, we are committed to supporting open source software to help improve digital content creation workflows and best practices. So before we jump into talking about creating content in the cloud, let's take a quick look at some of the work that studios are creating using AWS to scale their infrastructure. Okay, let's talk about some of the basic cloud components that are necessary when setting up studio infrastructure. Recently, we have seen a lot of studios who are interested in understanding what would be possible if they migrate to the cloud. Studios have been bursting their render farms to the cloud in order to scale their compute when they reach capacity on-premise. But now we are seeing companies take advantage of scaling their compute and their workforce. By moving their entire infrastructure to the cloud, including the actual workstations that their artists work on, they are able to elastically scale their teams as needed and work across multiple locations. This flexibility has become especially important now that studios are working remotely. Studios like HiVFX, whose team was able to migrate their entire pipeline to AWS, providing incredible flexibility to their workflows. The approach that HiVFX has taken allows them to reduce their overhead costs, freely scale their team to take on projects of any size, and be location independent, which allows them to hire the best talent from around the globe. So how do studios like HiVFX accomplish this? To begin building a cloud studio, the first step is setting up a virtual private cloud, or VPC. All of the cloud resources used by your studio sit within the VPC. These resources include storage, workstations, directory services, render resources, and others. Your artists can connect to your VPC over the public internet or via a direct private network. And to centrally manage your content and make it available to remotely distributed artists in different locations, you can configure cloud storage. This storage will house all of your project data that your artists need access to. And for your active project storage that needs to be performant for your artists, you can use Amazon FSx for Windows or Lustre, or you can use one of our partner storage solutions such as Cumulo or Weka. This storage will get mounted directly to your artist workstations. And for your repository storage or for backing up and archiving projects, you can utilize affordable and efficient storage solutions like Simple Storage Service, also known as Amazon S3, and its various tiers. Since we'll be talking about different types of services and compute instances on AWS, it's important to understand the pricing models of EC2 and how you might use instances based on your workload. Each of these pricing models has its place and use cases. On demand is great when you have unplanned usage and you need capacity as soon as possible. When you know you'll need a certain amount of capacity over a longer period of time, reserved instances are an ideal way to save. And then spot instances, or spare capacity, are ideal for fault-tolerant workloads that require a ton of compute, such as rendering. And creating a mix of these pricing models will help optimize costs and ensure that you have the right amount of compute. So once you have the foundation of your studio infrastructure set up, you can configure virtual workstations for your artists. From the artist's point of view, the virtual workstation is their entry point into the cloud infrastructure. Here's a quick video to give you an overview of virtual workstations.
Get ready to rethink creativity and transform the way you work. Whether you specialize in VFX, animation, or video editing, you can find freedom in the cloud and get high-performance simulation and design with virtual workstations on AWS. Enjoy the flexibility of scaling at speed and take on bigger projects. You can go from 2 to 200 workstations in just a few clicks and dial it back whenever you like. Importantly, you'll only pay for what you need. What's more, with the broadest and deepest global footprint, you'll be able to collaborate with the best creative talent worldwide. With virtual workstations on AWS, you can work from anywhere and make use of the latest software and hardware. So, how does it all work? Running on Amazon EC2 G4DN instances, our virtual workstations feature NVIDIA Quadro technology and are powered by the latest generation of NVIDIA graphical processing units, the NVIDIA T4 Tensor Core GPU. Sophisticated streaming protocols such as Teradici PCOIP or NICE DCV are employed, which means you stream pixels instead of data, resulting in a more efficient and secure creative process. Additionally, the Amazon Virtual Private Cloud will enable you to customize your own virtual network so you can meet the most stringent security requirements, including the requirements of the major studios. Are you ready to reimagine your studio? Then let's get started. If you want to learn more about virtual workstations on AWS, we'd be happy to help.
Let's take a closer look at some of the benefits of moving your artists to the cloud and using virtual workstations. Not only will you be able to take advantage of virtual workstations with high-performance graphics cards that can handle all of your artist's work, you'll be able to scale at speed, which means that you can scale the power of your artist workstations depending on the complexity of their tasks. And you can also easily scale up the number of workstations to fit the size of your team. And your team can now focus on what they do best and spend less time upgrading infrastructure. Centrally managed data means that you can now access what you need from anywhere, and you're no longer tied to a specific location. And of course, you can easily set up workstations for your artists with all of their favorite tools such as Autodesk Maya, SideEffects Houdini, and Foundry's Nuke. To run these applications, you need high-powered GPU workstations. Amazon EC2 G4 instances are optimized for machine learning application deployments such as image classification, object detection, and language translation. They are also cost-effective solutions for graphics-intensive applications such as remote graphics workstations, video transcoding, and game streaming in the cloud. What we will cover today is the use of G4 instances specifically for graphics-intensive applications. G4 instances provide the latest generation NVIDIA T4 Tensor Core GPUs, up to 1.8 terabytes of local NVMe storage, and up to 100 gigabytes per second of networking throughput. Our use cases will center on media and entertainment. However, this workflow is applicable to other industries using digital content creation tools such as architecture, engineering, construction, and manufacturing. In order to connect to a G4 instance for interactive work, sophisticated streaming protocols such as Teradicci, PC over IP, Nice DCV, and Remote Desktop are key components to making virtual workstations possible. By streaming only pixels to your artist's monitors and not transferring actual project data to their local machine, artists are able to work securely and efficiently. Of course, having a super fast machine is only part of the equation. It's also important for that machine to be located near the artists. Once you move your studio infrastructure to AWS, you can begin to take advantage of all the benefits that the cloud has to offer. One of the key advantages of using a virtual workstation in the cloud is AWS's global infrastructure, which includes 24 geographic regions. These regions are connected together with AWS's backbone networking. AWS's global infrastructure supports regions situated near visual effects and animation hotspots near Vancouver, Montreal and Toronto, London, and Sydney. And some of you might be thinking, but what about Los Angeles and Hollywood? How close is the nearest region? Luckily for you, the very first local zone is located in the LA metro area. A local zone is a new type of infrastructure deployment that places compute, storage, database, and other latency-sensitive services closer to you. Local zones are particularly useful if you want to leverage cloud-based virtual workstations because artists require ultra-low latency. All of the infrastructure that I just went over is what our internal production team uses to do virtual production. We have artists in 3 different regions all collaborating together in the cloud. So let's take a look at what this looks like in practice. Let's say I am a new artist on this project and I want to start doing some lighting and compositing. An admin on my team would simply spin up a new workstation in the region that I'm using, and they will launch using a pre-configured launch template. When a workstation is launched with this launch template, a new machine starts up with all of the software that I need to do my work already installed, our shared storage mounted, and all of the custom tools and pipeline for our studio configured. As soon as the machine is up and running, I simply grab the IP address of the workstation and connect to it using DCV. I log in with my Active Directory login and password, and once I'm authenticated, I can launch a file to work on. Internally, we are using Shotgun to manage our project, and are using the Shotgun toolkit as the base of our pipeline, which manages versioning, publishing, and configuring our launch environment. So I'm going to launch Maya through the Shotgun desktop app, and it will set up all of the custom tools, the menus, and the environment variables needed to work on this project. Shotgun will also present me with a menu that I can use to navigate to the shot and task that I want to work on without having to worry about knowing which version is the latest. So once Maya is open, I can navigate to the shot that I want to work on and select the task within that shot that I want to edit. And in this case, I'm going to open shot 120 and edit the background lighting file. And once the file opens up, I can make a change to one of my lights. So I'm going to grab the light that is affecting the clouds in the scene and increase the brightness. And to see the change that I made, I'm going to kick off an interactive render. This allows me to see what the current frame looks like and make sure that I like the change that I made. Now, if I want to render out all the frames from this shot to do some compositing, I'll use the deadline submitter that is installed in Maya and submit a render to our farm. And if we jump over to the deadline monitor, we can see the render is queued, including all the tasks associated with that render. Let's jump back over to the AWS Management Console, and we can see that the Deadline Spot event plugin is spinning up Spot instances to act as our render workers. And if we go back to the deadline monitor in DCV, we can see that those workers are now starting to pick up my frames. We're going to jump ahead and we see that one by one, the frames finish rendering. And now we can open a compositing tool such as Nuke and start layering in foreground elements and making any necessary adjustments to the image. So this is what our lighting and compositing workflow looks like. And we have workflows set up for all of the steps of the animation pipeline, including layout, rigging, animation, set dressing, effects, and character effects. Infrastructure configurations like this make it possible for studios to work with remote artists. Like The Molecule, where artists take advantage of virtual workstations on AWS so they can collaborate using tools like Nuke, Maya, Houdini, and other digital content creation tools, all while working from home. So you might be thinking that all of this sounds great and you're really excited to start exploring how your studio can move to the cloud, but you're just not quite sure what the next step is to getting started. There are two paths that I'm going to introduce you to that will help you get started exploring virtual workstations and creating content in a virtual environment. The first path is a self-guided set of tutorials for people who want to learn to build a cloud studio themselves. This solution results in workstations, storage, and a render farm. And then the second path is an automated template that helps you to easily deploy your first virtual workstation for testing content creation on AWS. Let's take a look at the first option. This solution is meant for those who want to understand all of the technical details that go into building their own studio infrastructure. This step-by-step process was written to be used by studios with little to no prior cloud experience. And while writing these tutorials, we kept small studios in mind who may not have dedicated IT people to set up studio infrastructure for their artists. We wanted anyone to be able to follow the instructions and build a custom cloud studio that fits their needs. These tutorials are accompanied by simplified graphic illustrations of each component that makes up the studio infrastructure. Going through the tutorials does take some time because you will not be using any CloudFormation templates and will be deploying all of the resources by hand. This process will walk you through creating your own VPC, spinning up virtual Windows workstations, configuring an FSX volume as shared storage for your team, building a render farm, including a Windows render scheduler and Linux workers, and adding users to your studio. These tutorials allow you to build the base for a full end-to-end solution. Here's an illustration of what your finished studio infrastructure will look like. you can see the users connecting to workstations that are attached to a shared FSX volume and a render farm that uses the ThinkBox deadline spot event plugin to automatically scale up and down based upon how many jobs are in your render queue, which is managed by your render scheduler. There are also Amazon machine images and launch templates set up for your workstations, which allows you to easily increase the number of artists in your studio and give them access to all of the tools that they need to do their work. In addition to the main tutorial series, there are add-on tutorials that allow you to further customize your studio. These add-on tutorials explain how to upgrade your workstations to stream with Teradici and to deploy your render scheduler and your workstations as Linux machines rather than Windows. Now let's take a look at the second option for deploying a content creation workstation using a CloudFormation template. This solution is a great way to test out what it's like to use a virtual workstation on AWS to create content. Minimal cloud expertise is required since you'll be using an automated CloudFormation template to deploy the infrastructure. It handles setting up a VPC, creating the networking subnets, and launching a virtual Windows or Linux workstation with a login. And your workstation is configured to work with the Teradici streaming protocol. Blender, which is an open source animation software, is installed on your virtual workstation, so you can start using it to create content right away. Your virtual workstation can also be connected to an Amazon S3 bucket, so it can directly access any project data that you want to upload. This solution allows your artists to easily evaluate working in a virtual environment by comparing the experience of working on an AWS virtual workstation against your on-premise equivalent. Let's take a look at a diagram of what the deployment looks like. And just so you know, the automated CloudFormation template deploys everything in this diagram. So it deploys a VPC configured with a public and a private subnet in your chosen AWS region. A Linux or Windows Amazon EC2 G4 workstation is launched, running the open source Blender application, but is suitable for running other VFX applications as well. An internet gateway is created in the public subnet to access the public internet, and a network address translation gateway is created in the public subnet to allow your G4 workstation to initiate outbound connectivity to the public internet, but prevents the public internet from initiating access to your workstation. An optional Amazon S3 bucket can be added so that you can upload your test content to it. And then that uploaded content is then synced to your G4 workstation. The artist uses Teradici PC over IP streaming to connect their Teradici client, which is running on their local machine, to the Teradici server that's running on their G4 workstation. So this streams pixels from the virtual workstation to your artist's local monitor, and all of the project data stays securely in the cloud. Now, perhaps both of these solutions sound great, but you need a very specialized setup to handle the work that your studio does. For those of you that are new to AWS, and you might need help navigating the migration from your on-premise studio infrastructure to the AWS cloud, I'd like to introduce you to professional services. ProServe can assist you with deploying a solution relative to your existing infrastructure, customizing it to get you to an initial production-ready studio environment. This process is currently focused on animation and visual effects, but it can easily be translated for studios focusing on games, architecture, engineering, and construction. Now let's talk about a studio that exemplifies what it means to find success in the cloud. Untold Studios was started by a group of industry professionals who wanted to rethink what a creative studio could be. As a brand new studio, they weren't tied to any legacy infrastructure, and they wanted to leverage the latest technology to build a truly modern studio. By building their studio entirely in the cloud, they didn't need the typical upfront capital expenditure and infrastructure that is usually required to start a new studio. Their studio uses several AWS services to run, including EC2 Spot for rendering, Amazon S3 and Weka.io for storage, and EC2 G4 instances for their artists' workstations. With this infrastructure configuration, Untold has been able to scale their team to more than 85, and they can easily add new artists to their pipeline without having to purchase and wait on new equipment. This frees their team up to focus on being creative rather than standing up and configuring new hardware. Untold's directors, designers, animators, and script developers are all working completely in the cloud on shows like The Crown and commercials for Guinness, Churchill, Nissan, and Adidas. Let's look at how a studio like Untold would put their studio infrastructure together. An admin in an on-premise studio sets up a VPC in the region of their choice. To make the studio infrastructure more durable, subnets are created in multiple availability zones. The admin connects to their cloud infrastructure over a private connection using a streaming protocol. Performant file systems like FSX, Weka, or Cumulo are used as the active storage for project data, and S3 is used for backups, repository storage, and archiving old project data. Amazon machine images are created to spin up EC2 G4 workstations configured to run content creation applications. All of the data accessed via these remote workstations is secure and encrypted. Spot instances automatically scale up and down to handle all of the render jobs in the studio, and this is managed by AWS ThinkBox Deadline. On-premise artists connect to their workstations using a streaming protocol such as NiceDCV or Teradici. And then remote artists connect to their workstations in a similar way, but over a virtual private network. All access to studio resources is managed by the admin using directory services and AWS identity and access management. And once you move your infrastructure to the cloud, you can begin to take advantage of all of the AWS services available. So before we wrap up, I just want to really quickly recap what I talked about in today's presentation. I introduced you to the Creative Tools organization, and I went over some of the cloud basics needed to build studio infrastructure and spoke about virtual workstations. I gave you two options for getting started moving your studio to AWS, and I talked about how Untold Studios is finding success working in the cloud. For those of you who are interested in the two paths that I mentioned, here are some links to get you started. If you'd like to deploy a virtual workstation using a CloudFormation template to begin creating content, use the link to navigate to our GitHub page. Or if you want to build an entire studio in the cloud from scratch, check out the link with tutorial resources. And for any additional information or assistance, please contact the ThinkBox sales team. Thank you so much for joining me today. I hope that you have enjoyed this presentation, and we would really appreciate it if you would fill out the session survey. Thank you.